Salam, peace be upon you. Our story of change, part 14. What is conservation? Where we are. We have been building something careful. We started with a cup. The cup was whole. Then the cup was broken. Everyone saw it happen. But we refused to say, time passed, so it changed. That felt too easy, too magical, too hard for strangers to check. Instead, we built folders called state packages. Each folder holds a snapshot of something at one moment. What we looked at, how we looked, what we are allowed to claim, how uncertain we honestly are, and a trail so anyone can repeat our looking. Then we built receipts called update certificates. These receipts prove that one folder legally leads to another folder. They pass through 8 gates, like 8 checkpoints. If a receipt fails a gate, we do not accept it. We write a refusal certificate instead and put it in a special drawer called the negative archive, so we remember what did not work. Then we built an immune system. If we discover an old receipt was wrong, we revoke it. And we revoke everything that depended on it. We call this a revocation dossier. Then we built a graph. Dots are folders. Lines are receipts. The whole drawing is called graph G sub U. We said, a universe is not a place. It is a connected record. Then we built order, not from clocks, from chains. We said, S1 comes before S2 if you can walk from the first folder to the second folder by stepping along receipt lines. Then we built propagation limits. We said, a change can only spread along paths that have legal receipts with open gates. No distance, no speed. Only connectivity and permission. Then we built transformers. We said, a law is not an equation on paper. A law is a registered machine that turns one folder into another. Every transformer must declare its input types, domain guards, sealing requirements, invariance obligations, residual tests, uncertainty rules, audit recipe, and failure modes. Every transformer lives in a public registry. Then we build composition. We said we can put transformers together in a chain, but only if the types match and all gates still pass. When two different chains give the same result within uncertainty, they are equivalent. Now we have many transformers, many chains, many ways to change folders into other folders. And now we face a new question, a question people have asked for thousands of years. When something changes, does anything stay the same? The opening scene, the jar of marbles. Imagine we have a jar full of marbles. Red marbles, blue marbles, green marbles. We pour the marbles onto the table. They roll around, they mix together. But when we count them again, something interesting happens. The number of marbles is the same. The positions changed, the colors mixed, but the total number stayed the same. We say the number of marbles was conserved. But what does that really mean? Did we assume it? Did we believe it? Or did we check it? In our notebook world, we never assume. We certify. The big idea. Here is what we discover. Conservation is not a magic promise. It is not a cosmic rule whispered into the universe. Conservation is something we discover by checking update certificates. We say it slowly because it matters. Quantity Q is conserved under family F if and only if, for every valid update certificate under F, Q of S2 equals Q of S1 within uncertainty U. spoken gently. Q of S2 equals Q of S1 within uncertainty U. That is all conservation means. Not metaphysics, not mystery. Just checking receipts. What does that really say? Let us translate it into simple language. Suppose we have a transformer family F. Family F might be pouring marbles from jar to table, moving blocks from one box to another, shuffling cards, sliding coins across a table. For every legal update certificate in that family, we check some quantity Q. Maybe Q is number of marbles, total number of coins, total weight, number of blocks. If after every certified change in that family, Q stays the same within honest uncertainty, then Q is conserved under family F. Not because we want it to be, because every certificate proves it. The cookie count example. Imagine a tray with 10 cookies. You move cookies from the tray to a plate. The positions change. But if you count tray plus plate together, there are still 10 cookies. Now imagine a rule. Family F equals move cookies between tray and plate. Quantity Q equals total number of cookies. If for every legal move under F, the total number remains 10, then Q is conserved under F. But now imagine a new family. Family G equals eat one cookie. Under G, the number changes. So here is the key. Q is conserved under F, but not conserved under G. Conservation always belongs to a family, never by itself. Why we must say under family F? This is very important. Conservation is not global. It depends on the transformer family. If you pour water from one cup to another, the total water is conserved. But if water evaporates, the water amount in the cup is not conserved. If you slide the block across the floor, its mass is conserved. But if you burn the block, its mass as solid wood is not conserved. Some becomes ash and smoke. So when we declare conservation, we must always say, under which family, under what kinds of updates, under what rules. Otherwise, we are just speaking poetry. The marble factory example. Let us return to the marbles. Suppose we have 3 transformers. Transformer T1, pour marbles from jar to table. Transformer T2, shuffle marbles on table. Transformer T3, paint marbles red. Now we ask, is number of marbles conserved? Under T1, yes. Under T2, yes. Under T3, yes. So number of marbles is conserved under family F equals T1, T2, T3. But now imagine a new transformer. Transformer T4. Throw one marble away. Under T4, number changes. So number is not conserved under family including T4. See how careful we must be? Conservation always lives inside a family. The money box example. Imagine you have a money box. You take coins out of your left pocket and put them in your right pocket. Total money stays the same. But if you spend a coin at the shop, money changes. So we say, money is conserved under pocket transfer family. Money is not conserved under spending family. That is conservation in simple life. The balance scale example. Imagine a balance scale. You put apples on one side. You move apples from one basket to another basket on the same scale. Total weight stays the same. But if you eat one apple, weight changes. So weight is conserved under transfer family. Weight is not conserved under eating family. Everything depends on the family. The conservation rule. Now we write the rule clearly. Quantity Q is conserved under transfer for family F if and only if for every valid update certificate that uses a transformer from family F, the value of Q in the before folder S1 and the value of Q in the after folder S2 satisfy. QS2 equals QS1 within uncertainty U. If even one valid certificate in family F violates this, then Q is not conserved under F. If all certificates in family F satisfy this, then Q is conserved under F. That is it. No magic, no assumptions, just checking receipts. What if uncertainty is large? Sometimes uncertainty U is large. Maybe our scale is not precise. Maybe our measurement has error. Then we check. Does Q of S2 equal Q of S1 within uncertainty U? If yes, conservation holds within that measurement quality. If measurement becomes more precise later, we may discover conservation breaks. That is honest, that is science. So conservation can be versioned. It depends on measurement discipline. The conservation registry. Now we have something new, a conservation registry. This is a public list. It says, transformer family F, quantity Q that is conserved, uncertainty U within which it holds, the set of certificates that were checked, the date of last verification, where it holds and where it does not. If new certificates are added to family F, we must check them too. If any new certificate violates conservation, then Q is no longer conserved for family F. We update the registry, we issue a notice. This keeps conservation honest. It is not a permanent truth, it is a pattern observed so far. The counterexample ledger. Now we also have a counterexample ledger. This is part of the negative archive. When someone claims a quantity is conserved, but we find a valid update certificate where it changes beyond uncertainty, we do not hide it. We put it in the ledger. The ledger says, transformer family F, quantity Q that was claimed conserved, the update certificate that breaks it, the before and after values, the uncertainty, why it counts as a violation. This is how we learn. This is how we refine our understanding. Maybe the quantity is not conserved at all. Maybe it is conserved only under certain conditions. Maybe we need a different family. The counterexample ledger is not a shame file. It is a learning file. The broken pattern. Now imagine we find one update certificate where Q changes. What do? We do not panic. We check. Was the transformer really part of family F? Was the certificate valid? Did it pass all gates? Did uncertainty get underpriced? Did boundaries change? Was there an intervention? If after checking everything, the certificate is valid and Q changed beyond uncertainty, then conservation does not hold for that family. We update the registry. That is scientific honesty. No shame, just correction. The stress test, renaming again. Now we do our stress test again, because it protects against cheating. Suppose we rename everything. We add the same extra label to every folder. Phi goes to phi plus C. Do conservation statements survive? They must. If Q is conserved under family F, renaming everything should not change that. Q in the renamed folders should still match within uncertainty. If renaming breaks conservation, then conservation was depending on labels, not on real structure. That is not allowed. The predictions. Now we make predictions, not prophecies. Predictions like receipts, things we can check. Prediction 1. If Q is conserved under family F, then every valid update certificate in family F will show QS2 equals QS1 within uncertainty. If we find one that does not, the conservation claim is false. Prediction 2. Conservation is relative to transformer families. A quantity can be conserved under one family and not under another. This is not contradiction, it is precision. Prediction 3. If we expand a family to include new transformers, we must recheck conservation. The old certificates might still hold, but new ones might break it. Prediction 4. Conservation statements survive the rename everything test. If they do not, they are invalid. Prediction 5. If two folders are equivalent within uncertainty and Q is conserved under family F, then applying any transformer in F to equivalent inputs gives equivalent outputs for Q within uncertainty. These are simple. They can be tested. They can be audited. The failure signatures. Now we list the ways conservation claims can fail. Each failure produces a refusal certificate that goes into the negative archive. Failure 1. Missing family. Someone says Q is conserved without saying which transformer family. This is too vague. Refused. Failure 2. Missing uncertainty. Someone says Q is conserved but does not say within what uncertainty. Refused. Failure 3. Counterexample found. A valid update certificate in family F shows Q changing more than uncertainty allows. Conservation claim is false. Failure 4. Insufficient checking. Someone claims conservation based on only a few certificates, but the family has many. They have not checked enough. Refused until more checks are done. Failure 5. Rename failure. The conservation claim fails the rename everything test. It depends on labels, not structure. Failure 6. Family expansion violation. New transformers added to family F break conservation, but the registry was not updated. The old claim is now false. Failure 7. Uncertainty cheating. The claimed uncertainty is too small. The actual variation in Q is larger than claimed. Gate 6 would catch this. Failure 8. Quantity not in folder. Q is not something the folder actually measures. You cannot claim conservation for something you do not track. The child who understands. Imagine a child listening to this story. The child says, "So conservation means something stays the same when things change?" And we say yes, but we have to check. We have to look at the receipts. The child says, "Like when I pour water, the amount stays the same?" And we say yes, if you pour carefully. If you spill, it does not stay the same. So conservation depends on what kind of pouring you do. The child says, "So we have to say which family of transformers?" And we say, exactly. Water amount is conserved under careful pouring. Not just water is conserved. The child says, "And we check every receipt in that family?" And we say yes. If even one valid receipt shows the water changed, then it is not conserved for that family. The child says, "What if the receipt is wrong? What if someone spilled but didn't measure right?" And we say, then the receipt might be invalid. It might fail the gates. We only count valid receipts, ones that passed all 8 gates. The child says, "So conservation is about what actually happens in good measurements?" And we say, yes. Real changes with real receipts, not guesses. The child says, "And if we find a counterexample, We put it in the negative archive and we say yes. So everyone learns. So no one pretends it didn't happen. The child says, and we always say which family and how much uncertainty, never just it is conserved. And we say, yes, that is exactly right. The child thinks for a moment. So conservation is not a magic rule. It is a pattern we see in receipts. And if the pattern breaks, we update the registry. And we say, yes, that is the best way to say it. The main lesson. Let us say it one more time, in the simplest words we can find. A quantity is conserved under a family of transformers if every valid receipt in that family shows the quantity stays the same, within uncertainty. That is it. No magic, no assumptions. Just checking receipts. If it stays the same every time, it is conserved. If it changes even once, it is not conserved for that family. Simple, honest, checkable. What conservation is not. Now we say what conservation is not. Conservation is not a metaphysical necessity. Things are not conserved because the universe demands it. They are conserved because every time we check within a certain family of changes, they stay the same. Conservation is not permanent. A family might gain new members. A new transformer might break the pattern. Then conservation stops. We update the registry. Conservation is not absolute. It always comes with uncertainty. Nothing is conserved exactly, only within measurement error. Conservation is not universal. It always belongs to a specific transformer family. The same quantity might be conserved under one family and not under another. This honesty is what makes our story strong. The marble factory at the end. Imagine standing in the marble factory again. You watch marbles roll. They mix and scatter. But every time you count them, the total remains the same. You smile, not because you believe, because you checked, because you have receipts, because every valid update certificate in the pouring family shows the same count, within uncertainty. That is conservation in our world. Certified invariance. Not assumed, earned. What comes next? Now we have conservation. We have a way to talk about what stays the same across changes. We have a registry and a counterexample ledger. We have predictions that can be tested. We have failure signatures that tell us why a claim might be refused. Next, we will ask, how do we know what quantities exist to be conserved? How do we find them? How do we discover new conserved quantities? Those are for later parts. For now, we rest here. We have conservation as certified invariance, not metaphysics, just receipts and patterns. And we built it all from one simple idea. Q of S2 equals Q of S1 within uncertainty U for every valid update certificate in family F. That is part 14. That is what conservation is. That is our story so far. Always, peace be upon you.